This conference will now be recorded.
Okay.
So guys, this is Kumar here. Let me give a quick intro. We have Chetan Chaudhary, who would be our trainer. He has extensive experience on performance testing and performance engineering. So he has close to 15 years of experience, guys. So, Ch Chetan, there seems to be a lot of background noise.
Okay, is it from my side? I think no one else is on
Let me
mute.
let me mute myself just to check if it is on my side. Hang on 1 second.
Are you still able to hear my voice clearly?
Yeah, it is clear now. It is clear now, Chetan.
Yeah. Okay. Okay, I think
So you can carry on, Chetan, because there seems to, if I unmute myself, there seems to be a lot of background noise. So
yes.
as I've told everybody, uh, you know, please introduce a little bit about yourself and we'll get started. And we are not able to see your screen in case if you're sharing.
Yes. So I'm just opening a blank sheet so we can start the topic and uh, okay, so let's start. I'm sharing my screen. Please let me know if you all able to see whatever I'm sharing. So is it visible now? Whatever. Okay, so I expect the answer from all the other audience.
Yes, it is visible.
Okay. Okay, so let's not waste much more time and we'll just get started. Okay, so this, as we all know, that this is about performance engineering, and this is just a demo session for performance engineering. So before we start any demo, let's understand what is the basic difference between performance engineering and performance testing. Okay, so we expect, as Kumara might have already explained to you, the basic requirement for this training is that you should be at least acquainted of performance testing region. So you should be at least having some working experience on performance testing, so that you would be able to move to the performance engineering domain. So just I mean, as we already know that what is performance testing, what we do under performance testing, and what are all the things. So everything around PT and PE revolves around, let's say, one word: bottleneck, right? So the purpose of doing whole PT session is that we are finding the bottlenecks of application, and the purpose of PE is that how do you are fixing it. So, in a layman terms word, we can explain that the basic difference between PT and PE, that PT is doing is giving us answer to the what is the issue, what is the bottleneck, and P we are giving the answers for the why. Okay, so let's categorize it. Let's say, for example, you are having you're testing an application, load testing an application for which you're doing SLA based testing, and you are observing that high ART. Okay, so this is the issue, right? So in PT, as far as the performance tester is concerned, he would be reporting that this is the problem. The bottleneck is that high response time. But for PE, for a performance engineer, he would be more keen to know that why this response time is high, right? We know the issue, that what we know the what's that response time is high, but why it is high, right? The same way we can say that, for example, let's say some of the memory is getting utilized. So let's say there is memory utilization is exceeding, which is a bottleneck. So this is a issue. So what is the issue? Memory is getting increased, memory is reaching out. That is for the performance tester. For performance engineer, why this memory is getting increased, why this memory utilization is being increased, and how do we can fix it. So in short, the role of performance engineer comes where performance testing is ended. I mean, when a performance tester tests application, load test application, he gives the output, he gives the analysis that what is the bottlenecks, what are the issues he is able to find, and then the role of performance engineer start that how and why these issues are coming and how do we fix it. Okay, so in many organizations, you might have seen that there are some separate teams for performance testing and performance engineering. So the main reason for having some separate teams is like that. So they want performance engineers to focus on why and how. Let's say why and how. So why this problem is occurring, why this performance issue is there, why this bottleneck is there, and how to fix it, so that it does not reoccur. So nowadays you can see that in organizations are demanding a profile which is comprised of both. So they just don't want you to know PT, they are expecting PE out of you. So they want you to know little bit of performance engineering as well, right? So it's again all the gimmicks of cost cutting and all those things, so we will not go in that part. We will be focusing on the technical part. So as of now, any questions to anyone? Anything is not clear, or any other clarifications needed for what is PT and what is PE? Please let me know. Hello, am I audible enough?
Hello?
Yes, so
Hello?
yeah, so any kind of clarifications needed for topic I just have explained, that what is the difference between PE and PT, or we can continue.
We are good. I think you can continue.
Okay.
Yeah, it's good. We
Okay.
can continue. I just want, do you have any course outline? I don't know whether you giving course outline. This is my first time for your class.
Mm-hmm.
Do you have any course outline, please? How long is your class? That one. Yeah. Or that is going to be after the demo?
I'm not able to hear you clearly, Mido. I mean, what you are actually expecting?
Okay, let's continue. I will ask the question at the end of the class. Let's continue.
Okay. Okay, so this is a demo session. So for this demo session, we will be going through the well-known topic for everyone. That's GC. Okay, so I have prepared a small PPT over here for GC, and we'll just go through some of the things for GC in details. So as it's a demo session, we will not go in entire deep, but I'll just give you an idea. I will just give you a food for thought. So how that sessions, the upcoming sessions would be. Okay, so this is what is the agenda that we will be covering under GC. So what is garbage collection? What are the KPIs for garbage collection? How to enable the GC logs? I will also show you a demo that how do you do it manually. I have a sample jar file, and we can also see the GC log file, and we'll also discuss about the different types of tools that are available in the market for garbage collection and analyzing that logs. And the last two parts, how to tune GC and which GC algorithm to use, that I left for the actual sessions to start. So we are covering the first five topics, first 5 points under the garbage collection. Okay, so as we are very much familiar with what is garbage collection. Okay, so because we are in day-to-day life, most of the applications we are having, we are using this garbage collection phenomenon is being used. Okay, so just to give you a brief idea that how this garbage collection comes in the picture is that, so you might be knowing that most of the time the development language is nowadays is Java and all the object-oriented program languages, right? So before Java there was only C, right? So in C there was no any concept like of memory management. So it came with C++ and then C sharp and on and so on and so forth. But within C there was no concept of like memory management. Okay, so to address this issue when Java was being developed, so they have they had something different in mind. So they wanted developer to concentrate on writing the code, every every other parts, so that has to be taken care by the JVM itself. Okay, so the Java GC is in this that's the reason the GC came in picture. So what GC actually is doing is it is collecting the memory, it is collecting the objects which is not referenced by the live objects in the JVM or live objects in the application. Okay, so we all know that when a GC occurs, it is a general phenomenon that is called as a stop the world process. Okay, so whenever a GC is getting executed, JVM is supposed to pause all the activities, whatever it is doing. So it also includes the business threads, it also includes the application thread. So everything will stop for GC to work out. GC will collect all the garbages, and then JVM will resume its activity. Okay, so that's why GC has so much impact in or importance in your application performance. Okay, so this is the basic reason, because when a GC occurs, entire JVM is stopped. So that is called the stop the world process. So as you can see in the screen, this is the stop the world phenomenon. Okay, so as I already explained that the Java developer does not need to explicitly remove the memory allocation. So GC comes in picture and GC do the most of the things. So what happens in GC is the objects are which are unreachable, the references for the new objects from the old objects, which are really small in number, so these are getting collected, they are getting removed, and the space is being freed for the upcoming objects, the newly getting created objects. Okay, so a small introduction of heap, JVM heap. So we will not go in too much details. I'll just explain you the overview that you might also knowing by this time you might also know that there are some sections of heap that we have young generation, we have old generation, then there are some other sections that we will see in a detailed session for heap, where I will explain you all the different sections and what what every section is used. So in the screen you are seeing this permanent generation section. So from the Java 9 and onwards, this permanent generation is termed as your meta space. You might have been heard about it. So it is sorry, I think I got my screen sharing is stopped. Okay, so this is the meta space in the upcoming Java. So you can see from the the screen that how allocation happens to the young generation, then it gets promoted to the old generation, and in the same way the objects are getting created in the young generation. So the young generation is the first arrival space for the new objects, and most of the times the GC will start from young generation. So when old generation gets reached to its limit, it will start collecting the garbage, and it will GC will get triggered, and it will remove the objects which are not referenced back. Okay, so the same way we have the heap memory plotted before and after a GC. So this is a diagram. So this is a theoretical explanation. We will also see it through a live example, that how objects are getting moved. So you know that there is a young generation, we call it as Eden space. Then there is a survivor. So between Eden and old generation, we have a survivor space. So you might also know that it is also categorized in two different sections. So S0 and S1. So there are two spaces for survivor, S0 and S1. So once the young generation is full, as you can see, this is full. So the GC gets triggered, and GC will move this object to the S1 survivor, S0 survivor. So it is for most of the people call it as a from and to. S0 and S1, it will call as a from and to. These survivor spaces changes their roles in between every GC cycle. Okay. So for example, once a GC is run, a minor GC has been run on the young generation, it will collect the objects and it will move it to the survivor S0. Now for the next GC cycle, again the objects will be marked. So objects will be checked from S0 and Eden space, and if they are still used, the objects in S0, if they are still used, they will be moved to the survivor space 2. Survivor space 2, I mean TO2, that is S1. Okay, so this cycle will happen. So I will show you this through a live example, and so that you know it will be helpful to understand how actually it is happening. So the basic idea is that why we need to understand that why the GC is because you know overall for a performance tester, only what matters is that GC is happening and what is the GC count, what are the GC count. But we also need to make sure, we also need to understand when a GC is happening, what are all the areas of memory, what are all the areas of heap that are being targeted. Okay, and we also when we also see that there is an issue with GC of the application, so we need to be very much specific. If you are giving an analysis to the developers, if you are giving some engineering recommendation, you know, to fix the GC issue, so you need to be very much specific with proofs that boss, this is the issue with your memory structure, and this is the GC which is happening, which is actually causing out the outrage, memory outrage in the application. Okay, so that's why GC is so much important. Okay, we will go through the detailed structure when we have an actual session. So as of now, this is the way that a GC is being triggered, and after a GC is happening, you can see that young generation is freed up. Now we have objects in the two survivor space, that is S1, and few of the tenured objects are promoted to the old generation. So this happens through the process of promotion. Young generation gets the new objects, whatever are referenced back, again they will move to the survivor spaces S0 to S1. Again, someone may have asked you that what is the criteria for moving from survivor 0 to survivor 1, then again from survivor 1 to survivor 0. So there is one specific threshold that we call it as a maximum tenuring threshold. Okay, so by default for Java hotspot JVM, it is 15. Okay, so let me just open a pen wala tool. Okay, so I can write it on the here, write it on here. Okay, so this is maximum tenuring count is threshold is 15. So what does this number means is, once a object is moved within survivor spaces 15 times, okay, when from survivor S0 to S1, again from S1 to S2, so if this movement is happening for 15 times, then this object will get promoted to old generation. Okay, so this is something that most of the people don't know, and why it is important, we will again discuss it when we when we see a live demo. Okay, is it clear till this point? Any questions, any doubts?
Hi Chetan, this is Chandan.
Yeah, Chandan.
So you just mentioned that maximum tenuring threshold is from S1 to S2 or S2 to S1.
Yes,
So
yes.
my question is, what is the
Mhm.
threshold for from young generation to survivor space?
From young generation to survivor space. Okay, so there is no specific threshold kind defined for young generation to survivor space, but there is a limit. So let's say for your, if your young generation is of 12 MBs, so there is a memory threshold, so which actually is calculated by JVM itself. Okay, so if young generation is of size 12 MB, so let's say it will JVM will keep somewhere around 9 or 10 MBs maximum threshold for the objects, the memory space. So because because JVM does not want to young generation to get full and block the entire space for the new objects that is getting created. So when this reaches the space, and when the young generation reaches up to the 9 or 10 MBs, then a GC will be called again, and then these objects are stored in the survivor space. Why this rule is not allowed for young generation, it's a very good question, Chandan. First of all, because this maximum 10 tenoring threshold, if we put it at young generation, because we know that young generation is the very much first entry of your object in this JVM space, right? And we cannot put this on the young generation because it will be a too much hectic work for JVM. So JVM has to work a lot for it will have to scan each and every object which is the object, and when we need to move that object to the survivor space. So instead it is actually using the same the criteria for young generation, which is the space. We will see that how do we uh, how this young generation memory capacity is defined. We will see that when we see a live demo of a simple jar file, that and how the GC is getting triggered. Okay, so
Okay, thank
is it sufficient?
you. Thank you.
Okay, so now let's move forward to see what are the different types of GC we have. So I've listed out there's the 5 GC types as per the JDK 7. Okay, so serial GC, I also mentioned that this must not be used on an operating server, because serial GC means the complete list of the word process. Then we have parallel GC, then we have parallel old GC, then we have CMS, which is a very much favorite, and then we have G1, which is the upcoming latest GC for the JVMs. Okay, so to understand why there are different types of GCs, so JVMs are so extensively used in different types of application. Most of the time, the requirement from a JVM server or for an application server is different. For let's say for example, if this application, or let's say if this JVM is being used as a application server in your banking domain, or it's a banking application, so certainly for a banking application we would expect a very much higher throughput. Okay, higher throughput, by meaning higher throughput, we want a very less response time. So the JVM should respond quickly as possible. So for that we have different types of GC. So for that we will prefer the concurrent mask speed algorithm. Then there are different scenarios where the response time does not matter, but they want to yield maximum output from the JVM. So maximum throughput needs to be achieved from the JVM. So they can accommodate the stop the word process for a few seconds. So it doesn't matter if the application pauses for a second, but they want to yield more maximum throughput. So in that case, we use the serial GC or the parallel GC. So we will see this different types of algorithms and when to use these algorithms in an actual session, just for an introduction purpose. Okay, so then now moving forward, we have the next slide, which is explaining about this again, what how the serial GC works, how the parallel GC works. So just
Hello?
remember, sorry.
Can you please maximize your screen? The writing are very tiny, please.
Okay,
Thank you.
okay. Okay, it's okay now.
Correct.
Okay. So this is the screen just explains about what is your serial GC and how it is, how the algorithm is getting used. So just remember one thing. So may it be a serial GC, may it be a parallel GC, may it be a CMS. Everything, all the GCs are worked through this mark, sweep, and compact. Okay, so this is the algorithm. This is the basic algorithm used behind every GC. Okay, so they are marking first, then it is getting compact, and then it is getting sweep and compact. Okay, so there are a lot of confusion with guys that what is getting marked and what is getting swept. Okay, so I'll just give you an explain short. So whenever a GC is started, the first step which is the algorithm takes is the mark. So what it actually marking is the all the surviving objects. So when a GC is starting, it is actually scanning through the objects on the memory. Okay, so then it is taking from the front of the heap and leaving the surviving ones behind. So whatever the objects that are being marked are the objects that are being used. Okay, so there is a misconception within people. Few of the people have seen that the objects that have to be swept that are marked. So it's not the right case. The objects which are being used, which are being referred by the JVM, by the memory, by the younger objects, that objects will be marked and the remaining objects will be swept. Okay, and the last step of this algorithm is compact. Compact is nothing like just you might have seen the defragmentation of your Windows PC, right? Compacting is just narrowing down the blank spaces in between, because when an object is getting created, you may have a member, it may get created anywhere in the memory space, right? So one object may created here, one may get created here, one may created here. So when this GC is happening, when these two objects are getting collected by GC, this one object is only memory. So under the compact stage, this will reallocate here, the object will be here, and then this space is free for the upcoming objects. Okay, so this slide actually shows how the serial GC happens. So as you can see in the process, all these small arrows are representing the application threads, and then there is one GC thread, as you know. So as you can see that when a GC thread is running, there is no application thread running. That's why it is called as a stop the world process. Okay, and then again, this is the stage where your marking is happening. This is the next stage. Again, it resumes. Once marking is done, it resumes. Then the sweep and compaction is happening. Then application threads are again resumed. Same way, the parallel GC is there. What is the difference between serial and parallel GC is that because in serial GC, there is only a single GC thread which is doing all this work. Because it is that's why it is taking so much time. Let's say it is taking 2 seconds for collecting around, let's say, 50 objects. Okay, so when we are using a parallel GC, what parallel GC will do? Parallel GC will launch the multiple threads for the single GC. So instead of 2 seconds, whatever, when it is taking 2 seconds for doing the 50, collecting the 50 garbage objects or marking 50 objects, instead of 2 seconds, it will now take 0.2 seconds because it is divided between the threads. So that is the basic difference between serial and parallel GC, and it has its own applications depending on the requirement. So wherever is a throughput is required, so you will be using parallel GC, because it is saving you the time. It is saving you the time when where the JVM is stopping. Okay, so let's one more thing I just want to explain. The serial GC is suitable for small memory and small number of CPU cores. Because why? Because it is only targeting a single GC thread. And it will be not useful if you have multiple cores and if you have multiple number of CPUs. We would certainly want to use the multi-threading ability of the cores and multi-threading ability of your computer. So in order to get your things done quickly. So when a single core, so that's the reason why the serial GC is nowadays obsolete. So no one uses serial GC because no one is having a single core computer, right? No one is having a small memory and single core computer. So that's the reason my single serial GC is not being used so much. And you can also see in the bracket how to use a serial GC specifically. Use serial GC. So we will also discuss about the different types of JVM options during the upcoming sessions, where I can explain you the how do you use the specific algorithms or specific GCs in your JVM, where do you change these flags, what are the different flags available, and what each flag is used. Okay, now just moving to the next part. So there is one more GC, parallel old GC. Okay, as you can see it, the basic algorithm for every GC is same: mark, sweep, and compact. In the parallel old, there is a summary step. As you can see in between, there is a summary step. Sorry. So in the summary step, what is happening is the JVM is actually identifying the objects which are surviving, and it is separate. These objects are getting separated for the areas that GC has previously performed. So that's why the sweep is happening on the mark sweep compact algorithm. So it goes through a little more complicated steps. As you can see here, serial mark sweep compact collector, just one single GC thread is there, stop the world is there in between. But in the CMS or in the parallel old GC, you can see that first it is marking, then concurrent marking, then remarking, then concurrent sweep. That is the CMS. It's on the next slide. In the above picture, you can see that concurrent mark sweep GC is complicated. Because why it is complicated? Because it is doing everything concurrently. So marking is also done concurrently, sweeping is also done concurrently. What is the meaning of concurrent here is, when I'm saying concurrently, concurrent mark means you can say that these are the blue lines representing in between, and there is a yellow line, right? So this yellow line is actually a GC thread, and blue line is an application thread. So let's understand what are the difference between application thread and GC thread. So in the JVM terminology, we call it a daemon thread. A daemon thread is a thread which has been triggered by JVM to do its own work. You know, in a layman words, we can call it to clean its own sheet. JVM has this GC, right? So it is called as a daemon thread. There are different types of daemon threads which are actually working in the background for JVM to work. And there are different types. These are the application threads. So when we are saying that it's a concurrent mark, what does it actually mean is that application threads are also working at the same time when your GC algorithm is marking the objects which are not reachable, which is not the case with the serial mark sweep. You can see in the left side, when serial mark sweep GC is triggered, it will stop the application threads completely. So no application in going. That's why this CMS mark sweep collector is so much popular, because you know it is a very less impact. You can see stop the world pause. It is very less. It is just pausing for initial mark. Then it is once it has collected the data that what are the all objects have to be marked. Then that is happening in the concurrent position. That will happen concurrently. All the marks will be on concurrently. So the stop the word process, stop the word pause, is been significantly reduced. That's why the CMS is very much favorite these days for all the JVMs, for all the developers. Okay. And again, why when we use the CMS, when the response time for all the applications is crucial, as we already see. Due to the CMS algorithm, it is already reducing the stop the word pauses. So if it is 1 second here, it is 1/10 of it, so 0.1 second only. So that's why the CMS is very much popular, and the basic purpose of using CMS is that we are getting a very good response time for our application. So as I already mentioned in the previous slides, that for banking application, that most common algorithm you will see is a CMS. Again, then how do you use the CMS algorithm? You see that you need to use this flag -xx, use conc mark sweep GC. Okay, but with these few advantages, CMS is also having few disadvantages, which is again a high memory and CPU utilization, and the compaction step is not provided by default. So as you can see that we have mark sweep compact. So once the sweep is done, JVM is itself is reorganizing the memory to have it in a compact fashion. But in CMS we don't have the compact. You can see through the entire cycle there is no compact state. So we have to explicitly define the compact, which is again consuming some of the CPUs and memory. That's just the one or two disadvantages of CMS. Okay, now there is a G1 GC. Okay, so this is a latest G1 GC algorithm. So it is actually a comprised mixture of both CMS and a parallel GC. So unlike the previous GC algorithms where they work as for young generation, old generation, right? So in G1 there is no such concept. There is no young generation, there is no old generation. What G1 does is it takes your entire heap, though now for us it is divided in, let's say it's hidden space or young generation, it is survivor space, and this is old generation, S0, S1. So for G1 this entire is like one block, one entire one block of memory. So what G1 does is in the G1 this block is again divided in small chunks. You can see that blue and green blocks. So when a GC triggered, G1 GC is triggered, it is marking the small areas of the memory. So there is no segregation like hidden, young, and S0, S1 and old, nothing like that. It will just mark the small areas, and it will check for this area, is there any old objects? No, there are no old objects. Then again it will check in the next area. So what is happening when we are doing this kind of thing is that we are first eliminating the marking and this cycle. We are, because we are for marking the objects which are unreferenced, the GC has to traverse through all the objects that are present in your hidden space or as survivor space. In G1 it is not the case. G1 it is actually segregating the memory in blocks. So it has to, the work area for each and every block is limited. So it is increasing the performance at a very high pace, as well as the speed of finding out the objects which are not referenced is very high, and it will only clear the areas which has the objects. Like you can see these blue areas which are having the objects not referenced, that will only be cleared. Other green areas, then again compaction will happen and all the memories will be aligned again. So the thing is that why G1 GC is not being used so much as of now, because this is already is under discussion and it is not that stable. In most of the cases we have observed that when you use G1 GC, so after some period of time, some amount of time, let's say if you do an endurance test or a soak test, or even if within production after 20 to 24 hours, after 24 hours or 28 48 hours, depending on the capacity of the memory of the JVM, the JVM gets stuck. Yeah, it is entirely different issue with G1, which is actually being targeted by the different types of JVM vendors we have. So that's why it is not stable as of now. So all are again preferring the CMS, but it's good to know that what is the new kind of algorithm, G1 DC. When once this algorithm is stabilizes, once this algorithm gets a very good performance overview, then I am pretty sure that all the financials and banking applications will start using G1, because it is a very good GC algorithm which is having a very good performance. It is very fast. It is much faster than any other GC types. Okay. So just moving to the next slide. Now we have GC KPI. Okay, so we have talked so much about GC, what is happening in the GC, how the GC is recollecting the objects, but we are least focused about what are the GC KPIs. Okay, so when we are saying that we are monitoring a GC for any particular application, so what exactly you want to monitor? For a performance tester perspective and for a performance engineer, so GC KPIs are very important. So whenever we are saying that we are monitoring the GC, so what we are actually expecting to do is we need to monitor the three basic steps, three basic counters for GC. First is your GC time. Okay, so what is the average amount of time spent in GC by your JVM. Yeah, we have seen in the previous slide that we have the stop the world process, then we have marking, then we have sweeping things. So all these things takes time. So we need to check what is the average GC time, because this will give you the total amount of time where your JVM was actually not working. It was paused. Then you have maximum GC time. Okay, so what is the maximum GC time? It is a single GC event which has taken a lot of maximum time compared to the all GC other GC events. Okay, so why it is important? Because it is when a GC is pausing for a single event, and the pause time is greater than all the previous events, it's surely a concern, because the entire time a GC is getting triggered, your JVM is stopping the business threads, the application threads. So application threads will no longer be working, they will be paused. So it is again impacting the performance of your application. That's why it is very important to notice what is the maximum GC time. Then I've mentioned the GC time distribution over here. So let's not get into that distribution now. We will get through it when we start the actual GC session. Just apart from GC distribution, one more thing is important, to collect the number of GC counts. So what are the total GC is happening for a particular duration when you are monitoring a GC throughout the test? What is the number of count? So we have different. You might have seen the par new GC counts, and there are mask sweep counts. So these counts are also important. So how many times a GC is happening? Because this GC average GC time and maximum GC time, there is one more counter. You might have observed that there is it is percentage time spent in GC. For most of the JVMs and for most of the monitoring tools, we get most of the times it is for a Tomcat's JVM which is running on a Linux box, Unix box. We will see this counter percentage time spent in GC. So what does that mean is actually, so out of the JVM running, whatever the time the JVM is up, what is the percentage of time which is actually spent for GCs? So which is a very helpful counter for developer and for an engineer, because it gives you an idea that what is the, so let's say for my JVM was running for an entire 1 hour, and I can see that there are 60 seconds of time that is spent in GC. So I can say that 1% of my time, entire JVM running time was paused and it was consumed by GC. So these are very specific metrics that needs to be used when you are specifically tuning the GC, or when we are actually analyzing the application performance. Okay, we will discuss this more when we will be having an entire session for the GC. Okay, now let's moving to the next slide. How do we actually enable the GC? Okay, so I've given some screenshots. So till Java 8 there is a there were no changes in the GC enabling. So until Java 8 we have this print GC details and -xlog GC flag. Okay, you can see in the screen -xlog GC, and you just have to give the GC log path file, and then from Java 9 onwards we have only xlog :GC. The flag is changed. You can observe in the screen -xlog GC, and you just have to give the file path. So this flag is automatically predefined in Java 9. So Java 9 automatically print the GC details is already there in the Java JDK 9. Okay, we will see this through a running demo. How do we enable a log, and how do we get a GC log file? Okay, so now let's move to the okay, so this is different types of commands that how you get the GC. Okay, so now let's move the actual demo part where I'll show you that how this is actually working. Okay, so for this demo part I have this one jar file over here. You can see that this is nothing but a simple Java program which is running in background, and every 15 seconds it is just putting hello world to the output. Okay, you can see that there is a GC log file. I did a trial run yesterday, and I'll just show you this how does a GC log file looks, and we will again create it, no issues. So you can see that it prints the GC details first. What is the your JVM type? 64-bit server VM. So there are different types of VMs. When how it depends on how your application is launched. So there is one, you can see this is a server VM. There is also a client VM. Okay, Java hotspot client VM. So for it is for Windows 64. This is the basic information you get. All what are the JRE versions or you are using, what is the JDK version you are using. Then you have this memory's paging size, that is 4K paging size. Then what is the physical memory? So 8 GB, 8 gigs of RAM I have, out of which how much is free. Then swap memory, 1.3 GB is there, out of which how much is free. And then you can see this flags which has been given at the command line. So it is nothing but your initial heap size is your XMS, maximum heap size is your XMX, then the print GC and GC details, timestamps and all these things. Then you can see there are the different lines, GC allocation, failure and all these things. Okay, at the end of this file you can see a summary of heap. Okay, so this is nothing but the summary of total duration for entire duration your GC was running, or your JVM or your JVM was up and running. You will get the entire summary. Once your JVM is stopped or your GC stopped, JVM is killed, you will get this summary. So it will explain everything, that what is the total young generation bytes, how much was used, and you can see this 0x's. This is nothing but the hexadecimal addresses of the memory location. So starting and end point and the amount, it describes like that. So the address start at this point, ends at this point, and amount of this, the quantity of this. So likewise, so this is the hexadecimal address of the memory, physical memory location used on your system. Okay, so let's now just see how we can start the GC, and how we can see actually the GC happening. I will just delete this file. Okay, I have this command prompt open over here. Before that, I will also show you one Java Visual VM. So this is the previous running session of this. Okay, so everyone here knows about Visual VM. I think this is pretty much known as of now, because this is a tool that has been provided by JDK itself, Java itself. So how to find, in case if you don't know where to find the Visual VM, it will be in the bin directory of your Java. Okay, so I will just go back to show you. Say, let's say this is the C directory, program files in Java, in JDK, under bin. You have different types of tools are over here. We will also have one session to use this different tools, because most of the people don't know JConsole is also there, Jmap is also there, JHat is also there, JMC is also there, JFR also there. So likewise we have JVisual VM. Okay, so this is a very helpful tool. So actually basically it was developed for helping the developers to identify the issues previously when they are actually developing the code and starting with the initial phase of development. But we can also use it for monitoring the application. Please make one note over here. So JVisual VM is not allowed to monitor the production level JVMs. Okay, so it is already is only limited to monitor the single JVM, whatever you are running on this. If you want to use JVisual VM for production monitoring, now they have licenses allotted for that separately. So you need to get in touch with Oracle, and you can have JVisual VM as an entirely JVM monitoring tool for your production environment, where you can have a different details of, because JVisual VM gives a very good amount of details. I will show you. So you can see here now there is no VM. So this is the PID hello that I have executed earlier. Now we will run a new PID. Let's see. Okay, so before starting this, you can see that the command I am using. Okay, you can see that I am just running because it's a simple jar file. You can see this hello.jar. It's a simple jar file. I am just using a Java command to run. Okay, and as we are in the Windows, okay, Mido is saying this. Okay, and because we are on Windows environment, it is I'm running it through a command prompt. You can see that I have given some options over here. Java -xmx. XMX32M. XMX is nothing but defining the maximum heap memory size. The maximum memory heap for this particular JVM should be 32 MB. Then I have given two flags, -xx print GC details and -x log GC, and then I have given a path for a GC file. Okay, and the last argument is -jar and the path of your jar file which has to be run. Okay, it is clear now, this command, what we are running through this command. Okay, I take it as a yes, and let's just start and let's see what is happening. So now when I'm starting this, you can see that it is started printing out the hello world. Okay, so after every 15 seconds it will be printing the hello world. At the same time, let's see what is happening in the JVisual VM. Let me minimize it. I'll put it into this side. Okay. Okay, now we can see that there is a new PID is automatically detected under Visual VM. You can see that PID is there 20984. Earlier it was 5852. Okay, so I will close it. Let's open this one first. So once you double click it, okay, it's open in your new tabular session, and you have some basic information like what is the PID, what is the host, what is the main class, what is the argument, and whatever the runtime arguments you are given, you can see over here JVM arguments. XMS 32 MB, then you have given the print GC details, then xlog GC, and you have given the GC log file path. Okay, so this is the basic things you can see over here in the overview tab. Then moving to the monitor tab, you can see the memory utilization, CPU utilization, the class loading stats, and the number of threads. These are the four basic graphs. Okay, you can see that at the upper side you have these checkboxes available. So in case if you don't want to see threads, you just uncheck it, you will have the classes maximized. If you want to don't see classes, you uncheck it, you will have the CPU and memory maximized. Okay, but as a performance engineer, I would want to look at everything that I'm getting. Okay, so CPU, there is no need to explain what it is showing. It's obviously the CPU percentage, the CPU being used by this particular jar. Now here you can see there is a separate counter GC activity. Okay, so why GC activity is separated in the CPU uses part? So JVisual VM has an ability to specifically cater the differences between the actual CPU uses by your jar or by your application and the GC uses. Because I already explained that GC threads are the daemon threads that are been triggered by JVM inside. So they will also use the CPU. Correct. So we don't want to make we don't want to get it mixed with the CPU uses by the actual application sets. So this is very important, guys, understand it, because because when we are observing an entire CPU utilization, whenever we are monitoring a performance test or a load test, and we are collecting the counts, and we are seeing that the CPU utilization for this particular server was 75%. And in case if that server is running a JVM, we also need to make sure that out of that 75% of CPU utilization, what was the percentage of CPU which was actually spent for the GC activity. Why it is important? Because it will actually measure the performance of application. This kind of things are comes in pictures when we are actually doing a scalability testing, or when you are actually planning for capacity of application. In that case, you need to derive the footprint of your entire application. So you need to gather the data like what is the CPU footprint, what is the memory footprint, and you need to be very specific about this is the percentage of CPU which has to be used by an application if it has to be running on this many servers. Okay, so we will discuss this kind of small chunks in details when we are having an actual sessions. So as of now, these are the four graphs that you see on the monitoring screen. At the right side you can see this is the memory graph, heap graph, and we have two main counters over there, size and max. So what is the size and max? It is the same because we have just given the XMX flag. So the start size and the maximum size is same, 32 MB. Okay, you can also see this pattern is getting forming up over here, right? So this is nothing but a sawtooth pattern. We call it a sawtooth pattern in the performance world or analyzing world. It is a basic sawtooth pattern which is also helpful for detecting the memory leaks. Okay, now moving to the next tab, you can see there are this is a threads tab where you can see there are total live threads. Now there here you can see daemon threads, right? That is what I was talking about. So there are 8 daemon threads out of total nine live threads. So what is daemon thread? Daemon thread is the threads which is being used by your JVM itself for its own functioning. The same way on a Windows machine or on a Windows laptop or a Windows computer, we have few of the processes specifically aligned or specifically assigned for the OS task. So these processes are running to serve the OS, so to let the OS work on its own. So there's the same way daemon threads are the threads which are being created by JVM for its own purpose. So there are different types of daemon threads. We can see that RMI TCP is there. So by default, these 8 threads will be there in any application. Okay, so you say by default these threads will be running over there. Just a GC thread will come in picture when a GC is getting called. A GC thread will come in picture. You can also see that there are different colors. Okay, so this color legend is defined at the right bottom. You can see green is running, while purple is sleeping, yellow is wait, red is park, and this color is what orange, which is monitor, which is no, there is no more monitoring state right now. Okay. On this screen, you can also see at the right top corner you have this one button, thread dump. Okay, so just once you click this thread dump, before clicking on thread dump you need to select a thread, and then once you click on thread dump, it will the JVM VM will take a thread dump and it will store at a previous location that you have already mentioned for it. So we will also see about the thread dumps. How do we take a thread dump? What are the different thread life cycles are available, and how do we identify a thread if it is a locked or not? Okay, in the previous upcoming session. Next upcoming. Now next tab is your sampler. So I don't want to discuss it now. Sampler and profiler will keep it for the next session. Now let's move to the main part, Visual GC. So this is a plugin that we need to install. You will not have by default. You will have to install it. So how do you install it? I will also show you. Just go to tools, go to plugins, and you can see available plugins over here. Under available plugins here there are different types of plugins are available. So now because I already have installed it, I am not seeing that visual GC or GC plugin over here. So get it installed, and for your purpose I will also share this jar file with you so you can observe this what is happening. Now let's come to the main part. Okay, so whatever we discussed in the session, that the hidden space, the objects are getting created, you can see the hidden space is flowing up. And for your question, Chandan, as I remember how this tenoring is mentioned, right? So you can see over here, hidden space is allocated 9.5 MB, right? Out of which 6.5 MB is the threshold. So as now you can see, you can observe the right side, this part. Now whenever this reaches 6.5 MB, a GC will get triggered. You just observe this count. Now it is 4.5 MBs. Now 5 MBs. As soon as it reaches to the 6.5 MB, the GC will get triggered and the hidden space will be created. So I hope that will actually give you the proper understanding how it is working. Now see, it is reaching up to the 6.5 MB.
So is it auto calculated by JVM?
Yes, it's actually an auto calculation by a GVM. It is again depends on the ratio that the maximum size you are giving. Now I have given the 32 MB for this particular jar to run, right? So it already divided the 32 MB in different sizes. So old generation has got 21.5 MB, survivor space has got 3.5 MBs, hidden space is 9.5 MB. So total concluding to the 32 MB. Okay, so as you can see this hidden space uh, as soon as this reaches this threshold 6.5 MB, it is calling a GC, and the upper side you can see GC time, and there are total number of collections, how many collections are there. The last cause of GC is allocation failure. Allocation failure means there was no space to allocate for the new object. That's why the GC is being called. Okay, so the threshold there is in between 9.5 MB and 6.5 MB. This is for the shipper side, so that the hidden space doesn't run out of the memory. Okay, now let's move to the survivor space. Now see, you can see that S0 is now survivor space that we discussed. This is the from and this is the to, and they change the roles in between. Now we can see that in this graph right side you can see S survivor 0 was there. It was filled at some point of time. Now it is now then it moved to the survivor 1, then again it come to the survivor 0. So as of now the objects are at survivor 0. So if now again when a GC is happening, one or two GC cycles after, that survivor 0 will be moved to the survivor 1, and again if there are any objects survivor 1 which are still needed, those objects will again move to the old generation. Okay, there is one more thing I wanted to show you, because but it will not be visible now here, histogram, because it is not supported for the JVM. Why? Because we are running now you can see that S0 is moved to the S1. You can see that, observe, before it was under S0, now it is moved to the S1. So the histogram gives you the clear idea about the tenoring threshold I just told you about, right, during the session. Let me see if visual VM have its own histogram. It should have. It's also not there, not supported for this JVM. So I think it's a Java hotspot JVM. We are not able to see the histograms over here. Okay, so you can try this out in your own applications or whatever applications you are right now working. Okay, so you can see this now S0 is moved to the S1, and again old spaces, old generation has been increased. So guys, this is the way that we will be doing the sessions, the upcoming sessions. So there will be there will be just not just only the theoretical things, but we will also see that how these things are happening practically. So as you can see now, hidden space is again filling up. It will again, once it reaches to the threshold, it will collect, the GC will get triggered, and it will call to the it will move to the S0 and S1. Okay, so you also see we have, when we actually started this jar file, we have given the GC log file path, right? So we just quickly go and see what is written in the GC log file. Okay, now you can see this GC log file is there. I will quickly reload it. Yes, now you can see. So why GC reading a GC log file is so difficult is because it is not for GC. There is not a specific what we can say a template. We know there are different types of JVMs available in the market. Now whatever the JVM we are using now, it is a Java hotspot VM. Okay, so for different types of JVM, they have different types of methodologies they put the GC logs. Okay, so you will have a very approximately 60 plus options depending on what are the different types of GC details you want to print on your GC log file. There will be total about more than 60 plus options available for writing a GC log file. So there will be different flags inside it, and there will be different types of information. Okay, so as of now I will just give you the brief information. How do you read a GC log file and what is this line depicts. Okay, now let's take this first line. Okay, so you can see there is some number in the decimal, 63.593. So what is that number is? This number is the time in seconds where the GC started. Okay, so this is relative to the JVM start. Okay, so as soon as your JVM started, so from your JVM started, after 63 seconds, first GC was occurred. Okay, same in the next line, once your JVM started, after 138 seconds, your second GC occurred. Okay, now let's see in what is in the next column. We have this GC. Okay, this is the type of GC. Now because all these are the minor GC, you are just seeing the GC. If it is a full GC, you will see it as the full GC written over there here. Next is the cause of GC. Now you are seeing allocation failure. This is the sorry, this is the most common cause you will see in a GC log file, allocation failure for any minor GC, because that's the reason the GC gets triggered. There is no space for the new objects to come into the hidden space. That's why the GC is getting triggered. So that is caused as an allocation failure. Okay. Now you have the next flag, next bracket. You can see this. There is some information about young generation. So what is that information is? This is nothing but your young generation size before and after the GC. Okay, so before GC this was the young generation size, after GC it is the size, this is the total young generation size. Okay, same way this is the entire, for entire GC cycle the same. This is your young generation size after GC is happening, this is the recollected bytes, and this is the total heap memory size. That's the 32 MB that we have given, right? And the last point, last is the seconds. You can see this is the time taken by the GC, because it's so much information in a single line, and it is not yet finished here. So last bracket, you see this time, it is again this point, not 0.16427 second is distributed between the user, system, and real. So we will discuss what is the use of this specific counters, why we have this separate times, what is user, what is system, what is real, in the upcoming sessions or the actual live sessions. Okay, so as of now I think I'm done for the session. Any of you have any questions, any of you have any feedback about session, what else you would like to include in session, and yeah, please feel free to ask, please feel free to give the feedback.
Can you just tell us what is the course content and what you are going to cover?
Yes, so we will share your entire course content. So this is just a basic, the GC. I chose the GC topic for demo because GC is the most favorite thing for performance testing and engineering part. So the course content will go through it will go through like that. We will have first introduction of what is performance engineering, a small half-hour session of performance engineering. What are the different things that are being done in performance engineering, which is not a part of performance testing, but a performance tester can move on to the performance engineering. What are the different types of tools that can be used for performance engineering, and what are the different types of tools rightly available in the market that can be used. Then we will see the basic architecture of JVM. What is a JVM made of? A common architecture of JVM from a performance engineering standpoint. And then will we move to the heap architecture. What are the different sections of heap? How the heap memory is being used. Then sorry, then we'll move to the GC part, that we are one demo session we already had the GC, so it will also include the same GC things and much more details. Then we'll also see about the different types of monitors. What are the different performance monitors you need to take into account when you are actually measuring the performance, and what are the counters that are important for performance engineer to observe. Then we will also see about the AWR reports. How do you generate an AWR report at backend? How do you generate the ADM report? Then there are different types of counters available for database as well, which are less known for performance test and performance engineers. Okay, so inside GC we will also see the GC tuning. Yeah,
Chetan, quickly, sorry to interrupt. Can you show
yeah.
the code content that I have sent you yesterday if you have handy? Maybe if you display it on the screen, they can understand it better. Even though
Okay, I
it's not,
have it.
you know.
Okay. I have it on my message box, Kumar. I need to get it on the. Okay, let me just.
So if you have web WhatsApp, if you can open the WhatsApp on the web, I can, or I'm just wondering, is there a way I can send it? Because if you can display it on the screen, right, they will be able to
Yes.
understand it.
Yeah. I think yes. That would be a good idea. I have web WhatsApp already. I just need to scan that. Okay.
And while we waiting for you to start, how long is it gonna take? Duration of the course, please.
So, Sano, it's a 20 hours course overall. Okay. So, whenever there is a class, it will be a 1 hour class. That's how we have decided. So, it's close to 20 days. Okay. So, weekly, it will be
Okay.
4 to 5 days. So depending on the trainer's availability, and we know that, I mean, that these are all real-time working training staff that we have. Okay. So depending on the kind of work they have on the day, sometimes there will be a class, sometimes there won't be. So you got to be a little flexible. Typically, we'll decide upon the dates and the timings, but we will inform you upfront if there is any change on that. Okay. So on a week, there will be 4 to 5 classes. Okay, daily 1 hour. So it's a 1 month, close to 1 month course. Okay, that's how it will be, Sano.
Good.
Okay, so I have over here. So this is the course content if it's visible now.
Put it in a Word document, automatically it gets aligned, Chetan. Thank you.
Yes. I think Notepad++ will also do.
Yeah, Notepad++ will also.
Yeah. So this is the actual things that we are planning. We may also have some inclusions by as and when the requirement comes and as and when the topics we feel that is needed to be added. So we'll also include. So we have different types of things like CPU, what are the memory counters. So we already know, as a performance tester, we already know these counters. What is the CPU, what is the memory, but we don't know how do we actually relate it with the performance of application, right? Memory counters, how many memory? If even if you ask anyone what are the memory counters, so they will see you the maximum memory use, available memory use. But what is the actual use? There are very few people tell about the swapping counters, swap memory, right? It is very important as far as the performance of application is concerned. So swapping of memory is also important. So which is less, not given so much importance by performance testers. So for a performance engineer, it is important to know that how many times a memory swapping appeared, how many times there was a swapping in when a test was running. In that way, this will help him to identify the memory behavior, how the application is consuming the memory. So this kind of way we will have different types of topics. So most of the GC I already explained in your demo session how it is working and how the things are going on. So thread dump, we will also see how do we take a heap dump, how do we analyze a heap dump. Then AWR basics. What are the what do you look for in an AWR? How do you create and how do you generate an AWR? And then JFR is there, JConsole is there, JProfiler is there. So this is the course content. So I hope this was a nice session.
And regarding this, practical demos or sessions, so how you are going to show us? Is there any live application or how you will show us?
Yes. So we are planning to get a demo application first to get it deployed in our servers, and we'll also try to check if the same application you can also deploy at your own convenience at your own machine or your own desktop, laptop, whatever you are using. So we are actually trying to find out a simple sample small application that everything all these things can be covered across this application, and we can actually have this demo. We will cover the live session demo session over here, and you can practice it at on your own at your leisure time. So we are actually
Okay,
in
so
yeah.
yeah, so this is one aspect that is appreciated. But
Mhm.
another aspect is like we want your experience as well. Like you can share your experiences, whatever you have faced,
Mhm.
so that that will not be limited to only a sample application.
Sure, I can share my experiences, but the thing is that I will not be able to, give the details about what sort of application I faced that issue. I can give a general hypothesis kind of thing, or a general how what how do we term it as a case study. I can give you sure I will give an experience to whatever types of performance tuning I've done till now, whatever types of issues I found, the types of GC tuning I've done, the JVM tuning I've done. So I will prepare a case study and I will give you the details that this was the issue that was observed and what I did to counterfeit that issue, then how what I did to solve this issue. So I will give you a case study for sure, but I mean the details like what application was that and what is that will not be there. Okay,
No,
it will be a
definitely.
case study. Yeah,
Yeah, if it will be generic and it will it can give us some insight like
sure,
about the
sure,
different kind of scenarios and how to deal with it, then it would be great.
sure. Yes. Sure, I will have a case study. We can also take a case study. So there are different. You can also share yours case studies or whatever the issues you are facing in your current project or whatever the things you are working on. So we can try to discuss it and debug it. I will cover a simple one more session where we will discuss the case studies. Let's term it as a case study. So it will include everything, JVM tuning and whatever the performance engineering work I've done. I will do one or two case studies. So you will have a basic idea that what kind of for this particular kind of situation what is. So just to give you an idea, Chandan, so you these case studies are will be just for informative purpose, because you cannot take it as a template, because there are no certain things or there are no certainty of or there is very less probability of having the same issue and the same solution be working on it, right? So this case studies you take it as an example, whatever the issue that I have faced, I will try to elaborate at my extent whatever I remember. So and the things that I did to fix this issue. But if same symptoms or same issues, if you observe and if you try to utilize the same solution, it may or may not work, because because every day issue is a different issue in itself. So we need to actually drill down to issues and everything. So take it as a case study, but it is a very less probability that it will work with the similar symptoms issues or similar symptoms case or the problem that you may face. Okay, so we will the thing over here is that we are planning to make you think like a performance engineer. So we want to inherit that attitude, we want to inherit that skills that is needed for a performance engineer. So most of the work for performance engineer does is out of itself. So he or she, they already they all they already have to this kind of thinking pattern or this ability of thing. So that I have explained at the start of the session, that when a performance tester, what a performance tester does and what a performance engineer does. So performance tester is more concerned to identify the bottleneck, to find out why, what is the issue, right? So performance tester will give you that high response times are high, the memory is memory utilization is high, there are no threads are running out. So this is the comments of performance tester. For a performance engineer, the comments would be why the memory utilization is high. So he will dig down further, where what are the things, what are the objects which are taking the memory utilization to the high level, why my threads are running out, why the CPU utilization is high. So he is answering this whys, and performance tester is answering the whats. So this kind of thinking, this kind of ability has to be inherited, right?
Yes, that is what my intention is.
Yeah, so this we will, through the entire series we will try to inherit this kind of thinking, so through the various examples and all these things. So if you guys want, I will share this simple jar file with you and the commands. So you can you can have this practice at your home. You can just look what are the different things, you can explore the visual VM, what are the different things in the right now. We can see that there are 27 GC collections are happening. This is very I mean, when you see this kind of things, whatever the concepts you have, it helps you to understand it clearly, right? As far I mean, by far we know that theoretically there is a hidden space, there is a survivor space, there is old generation. The objects are getting, when a GC happens, objects are getting collected through the hidden space, but we don't see it visually. So when you see this kind of things, when you see this kind of graphs running at live session, the understanding of your concepts are pretty much clear. And you will be able to relate with your whatever application you're working on. So you will be also able to relate it and map that knowledge to your advantage, and dig down further in your analysis and upskill yourself. Okay.
Chetan, one more thing quickly here.
Yes, too.
Yeah, Chandan, regarding the application, so we will be we'll be deploying a sample application, and then we'll try to explain the concepts. But when it comes to your practice, okay, so we'll try to see, like, we'll give you the instructions as to how to deploy it on your own desktop or laptop. But for whatever the reason, if you're not able to do it, or there is an issue, okay, and all that, what we can do is we can give you a simple program, as in how Chetan has explained you right now with the jar file, okay, so that you can go to the command line and start executing the program, and then you will be able to start, looking at all these problems. Okay, so the intent is to give you as much experience as possible with the sample application. But if you are not able to deploy it on your own systems, okay, then we have an alternative as well. Okay, because I wanted to give this information upfront, because we coming and deploying on your systems, each and every system is a little difficult. Okay, so we wanted to set these expectations upfront. So Chandan, are you complete? I hope you.
Yes, I'm good.
Yeah, thank you. So you got to be a little flexible. So the idea is not about the application. The idea is to learn the concepts. That's how it should be. The intent, or the thought process. I want you to upfront. Okay. Thank you, Chan.
Okay, so I'm just stopping the recording, Kumar, and we'll conclude the session.
Yeah. Guys, any more questions? Neha, I think we have Neha, Sanoy, Anil. I'm not able to see because I'm connecting from the mobile. I'm not able to see all the members who have joined. I think we have Rakesh as well. So anybody has any more questions?
Yeah, this is Sano. I don't have question. I just have compliment. Thank you so much. This is so fantastic because ever since I've actually taken myself to be in this particular career, I've never seen something like this. You never see it, even in YouTube. You never see it live. And we really appreciate you. And we hope this course actually goes successfully. And that is it. We thank you so much. The demo is so fantastic, and I think the entire course is gonna be wonderful too. Yeah, that's it.
Thank you so much, Simon. Thank you so much for the compliment. Okay, as you know, this is a real-time, performance engineer trainer we have, and very extensive experience. So let's see how much we can, grasp knowledge from this wonderful gentleman, Chetan here. Okay, so thank you, Chetan, for spending the time with us and making this session happen. So I'll keep you posted. And when it comes to the actual sessions, guys, so we'll start from Monday. Okay, we'll take a little bit of break. In the meanwhile, we'll be figuring out a sample application, and we'll be deploying the application, and we'll keep the whole thing ready over this weekend. So we will have the actual session starting from Monday, most likely. Okay. So if there is any change in the plan, I will let you know on the WhatsApp group. And if there is somebody who's not part of the group, let me know so that I'll add it to the WhatsApp group. Okay. And somebody has not done the payment and you're interested, please touch base with me on a WhatsApp or email, guys. Thank you.
Okay.
Chetan, we'll wrap it up. Thank you so much.
Yes, Kumar. I'm just trying to find out how do I stop this recording.
And don't worry, it automatically gets stored. All you have to do is just close it.
Okay.